Good morning. As you may have guessed, this video is designed to teach you rocket science. But before I can teach you rocket science, I must first teach you logarithms. I want you to take the numbers 2, 3, and 8. If you raise 2 to the power of 3, you get 8. And the cubic root of 8, that is the number that, when cubed, is 8, is 2. Therefore, we can assume that these numbers are connected, like Pythagorean triples. If we have 2 and 3, we can get 8. And if we have 8 and 3, we can get 2. But what if we have 2 and 8? That's where logarithms come in. Logarithms tell you what exponent to raise to the base, in this instance 2, to get, in this instance, 8. That would be written out as log base 2, 8 equals 3, with 3 being the exponent. Let's try this out with another set of numbers, 4, 3, and 64. 4 to the power of 3 is 64, and the cubic root of 64 is 4. And log base 4, 64, is 3. Now you try. What do you have to raise 5 to get 625? Or log base 5, 625. Let's work it out. 5 to the power of 1 is 5, and 5 to the power of 2, or 5 squared, is 25. 5 cubed is 125, and finally, 5 to the power of 4 is 625. Therefore, the answer is 4. What? No! Stop! Wait! No! That's wrong! When we teach you how to make logarithms, not as long and painful of a process. Now, logarithms can be long, painful processes. Raising 5 to the power of 2 without not being 625, raising 5 to the power of 3 without not being the answer, etc. But there are some ways to make it not as painfully long. Firstly, you can multiply. Let's use the example log base 2, 64. Just keep multiplying 2 by itself until you get 64, and count how many 2's. Let's try. 2 multiplied by 2 is 4. 2 multiplied by 2 multiplied by 2, or 4 multiplied by 2 for simplicity, is 8. 2 multiplied by 2 multiplied by 2 multiplied by 2, or 8 multiplied by 2 is 16. 16 multiplied by 2 is 32. And 32 multiplied by 2, or 2 multiplied by 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 2 is 64. How many 2's is that? That's 1, 2, 3. It's 6 2's. Therefore, log base 2, 64 equals 6. Another way is to divide. What you do is you divide by the base and count how many times it takes you to get to 1. Let's try with the 2, 6, 64 example. 64 over 2 is 32. 32 over 2 is 16. 16 over 2 is 8. 8 over 2 is 4. 4 over 2 is 2. 2 over 2 is 1. Since we divided 6 times, log base 2 64 equals 6, which matches up with what the multiplication method told us. So let's put this to the test with log base 3 81. Well, oh, yeah, but that's not how you... I said no! Look, how much speed a rocket will create has nothing to do with tail fins or empty fuel tanks. Let me show you. Okay, now I'm going to show you the equation. Prepare yourself as it's rather long, but I will walk you through it. Here we go. Log base E, start mass, divided by the dry mass, multiplied by ISB, multiplied by 10 equals delta V. Firstly, you may have noticed that where the base would be is the letter E. E isn't a variable. It represents a number, the same way pi represents 3.14. E is also irrational like pi, but it's about 2.7. Fortunately, you don't have to do logarithms with E as the base on your own. Most scientific calculators come with a button for that, labeled LN. Secondly, what is M star and M dry? Well, M star is the mass of the ship at the start of the launch, where the fuel tanks are full. M dry is the mass of the ship after all the fuel has been used up. Lastly, ISB is how long, in seconds, it takes to get rid of 1 kilogram of fuel. ISB is like the efficiency of the engine. Yes, exactly. Do you want to put it to the test? Okay, so for our first mission, let's do something simple. Let's go to space. In order to leave the atmosphere, you need about 1,000 meters per second in delta V. I have prepared this rocket in advance. Let's see if it will do. There are two main parts to this equation, the logarithm and the ISP. To solve the logarithm part, simply divide the start mass by the dry mass, then find what you must raise e to get it. Then multiply that by the ISP in 10. This will give you the amount of delta V, literally change in speed in meters per second. This rocket has a dry mass, or m dry, of 7 tons, a start mass, or m start, of 21 tons, and an ISP of 100 seconds. So let's plug these numbers in and see if they work. We can start with the logarithm. Log base E 21 tons over 7 tons. 21 over 7 is 3, so we can type in log base E 3. So now we can all pull out our scientific calculators, press the LN key, type in 3, and press enter. This is the hard part over. Now all we need to do is multiply by the ISP, 100 seconds, and 10. And boom, you're done. There we go, 1,100 meters per second. That's much more than we need. Right now.
5, 4, 3, 2, 1, 0.